Okay, all right, it's on. Good evening, everyone. Well, as you all know, Game of Thrones is back, so we are in the best part of the year. So as you might have heard, my name is Yan, and I'm an engineer at a company called SpaceApe Games. We are the game studio behind some award-winning mobile games, such as Transformers, Earth Wars, Rival Kingdoms, and we've got a whole bunch of new games that are either fresh off the press or is going through a stealth alpha release somewhere in the world, which I can't quite tell you about just yet. And since the last time I was here in March, we've actually been acquired by Supercell, which I'm sure you've heard of. They are the undisputed king of the mobile games in the West. And before I left the office today, I was reminded to tell you that we are hiring. I know, it's cheeky. We're hiring across a number of different positions, including mid or senior level server developers. So if you're interested in working for a well-run startup and make mobile games for a living, come talk to me or check out our careers page. So on a more personal note, I've been using AWS since about 2009. And before joining SpaceApe Games, I was working for a company called Yabo, which is in the social networking space. And you can think of it as a mix of Instagram, Twitter, and Facebook. And while I was there, Lambda became a massive part of our architecture. In fact, the last time I was here, I talked about my experience moving from a monolithic backend system for the social network to an architecture that is event-driven, service-oriented, and with Lambda being the centerpiece that glues everything together. If you missed that talk, you can find the recordings and slides here, and also I put together a series of blog posts that details our experience of that migration. And of course, I didn't do that by myself. I had a very strong team working with me at the time. Some of them are here tonight. So Thomas, Scott, Diana, I'm sorry to do this to you, but can you please stand up and make yourself known to the room? Some of the best people I've ever worked with, and from what I gather, some may even be available for hire in the future. So if you've got an interesting project using Lambda, go grab those guys later on. So that's not all the jokes. So let's start with a nice news. That Lambda is finally PCI DSS compliant. And from talking to a lot of folks at different events, this is the news I've been waiting for before they go into the serverless world. But as more people go into this world of Lambda functions, what does it mean to the shared responsibility model? For starters, Amazon is now going to take over the responsibility for managing and securing the host operating system with all the associated network configuration as a part of the core competency. And it's great news for us because, frankly, as an application developer, constantly patching OS is just not my primary focus, and Amazon can do a much better job than I can. And in turn, that means I get better protection from attacks against known vulnerabilities in the operating system and hopefully prevent the next WannaCry virus. However, I'm still responsible for the security of my code as well as patching my third-party dependencies. And this year, we also got a new OWASP top 10 list, which you compare that to what happened in 2013, you see that apart from recategorization, very little has changed at the top. And if you go even further back to 2010, again, very similar list. So clearly, as an industry, we're making the jobs of these guys too easy, right? And the guys at the Snike, when they took a look at the data for top 50 data breaches that happened in 2016, they found that almost a quarter of them was caused by applications using components with known vulnerabilities. And that 77% of the top 5,000 websites from Alexa was using at least one JavaScript library with a known vulnerability, which may sound surprising, but when you look at how even the most popular front-end frameworks nowadays have had some vulnerability at some point, many of them were fixed shortly after being reported, but it's still down to you to make sure that you patch and update your dependencies. One such library is user agent, for example, and many others like it that uses regular expression. They tend to be vulnerable to regex denial of service attacks. And if you haven't heard about what the regex denial of service attack is, I certainly didn't know what it was until recently. Okay, so regex is quick when your string matches. It's slow when it doesn't, because you have to try many different combinations and backtracking and whatnot. Imagine if someone gives you a really long string, maybe in the thousands of characters long, that almost match your pattern, but quite, it means that you now have to do a lot of work to get the answer that it doesn't match. So it can cause your regex to run for a very long time. And imagine if your Lambda function is using an old version of user agent to pass the user agent header, you are now vulnerable to this kind of attacks. And if you're leaving your Lambda function with a very long timeout, then those attacks can start to become very expensive if it's combined with normal denial of service attacks. And just because you're connecting to your SQL database from a Lambda function, it doesn't stop you from being a target for SQL injection attacks. And unfortunately, even if you're using no SQL database, it doesn't mean that you're immune either. For example, MongoDB's query API has several attack vectors that can allow an attacker to launch an injection attack against your database. And arguably, DynamoDB's API makes it a lot harder, maybe even impossible to do an injection attack. And it's not one that I've heard of. If you know of a way to do it, please let me know afterwards in private so that I can protect against it, not to launch an attack, of course. But you're still vulnerable to other forms of exploits, such as cross-site scripting attack, for example. So the point is that even regardless whether or not you're using a SQL or no SQL database, you should still always sanitize your user input. And in the case of Lambda function, you should also consider sanitizing the output from your function so that you don't pass attacks and problems further down the call chain. Meanwhile, GraphQL has been picking up in popularity in the last couple of years, which is exciting news because I think it's a very interesting technology. And there's been quite a lot of adoption from the serverless community as well. And unsurprisingly, GraphQL also gets its own form of injection attack called the GraphQL injection. Ultimately, your query operators in your GraphQL query translate to some form of query in SQL or NoSQL database. So it is possible to manipulate them in order to launch an injection attack against your storage database in the back. But maybe more worryingly, we also found that a number of template engines has got code injection vulnerabilities. So these are the type of vulnerabilities that allows attackers to execute arbitrary code against your system. So if you're using Lambda with one of these libraries with this vulnerability, then it means that you're also vulnerable as well. And one of these libraries was Dust.js that was maintained by none other than LinkedIn. Well done, guys. But fortunately, this library is not actually widely used, at least not from the stats I can see on NPM. And also, the vulnerability was eventually fixed late last year. And the point I'm trying to make here really is that your application dependency is probably a much bigger attack surface than you realize, especially when you can take into account the transient dependencies that your dependency have. And in just about any language and any ecosystem, you find this kind of massive layers, many layers of dependencies. You find this in the Node.js for sure, but you equally can find it in the .NET or Java. And if your transient dependencies have a vulnerability, that means you will also likely be vulnerable too. That's why services such as Snike is very useful. It continuously scans your dependencies for vulnerabilities, and it alerts you and also try to patch it for you as well. And there's also a built-in integration with Lambda. So do check these guys out if you haven't seen them before at snike.io. Just give you a sec to take screenshots. And before we move on, just one more thing I want to mention about patching application dependencies. Unlike security updates for your OS, which are usually standalone, self-contained, and comes from a trusted source and can be easily applied, security updates for your application dependencies, they usually come bundled with some feature or API changes. That means as a developer, you often have to integrate with them, making code changes, and also to test them. And in some cases, they can also cause incompatibility between your project as well, maybe different components depending on different versions, and now maybe even force you to do lockstep deployment across multiple components. So it makes your life as a developer difficult when you try to integrate with these kind of changes regularly. So I can totally understand and synthesize with developers why they don't update their dependencies as frequently as they probably should. But do remember that your security is only as strong as the weakest part in that link. And as an attacker looking in from the outside, there's just a whole world of things that I can attack. And if we're making a movie, then of course I'm going to start my attack by targeting the physical infrastructure that are protected by armed guards. And depending on the genre, I may decide to go with a rather stealthy approach. Or maybe I'll just go in, beat up some guards, and blow some stuff, and just walk away like a boss, right? And of course, in real life, there's so many low-hanging fruits. No one in their right mind will actually do that. So if I'm an attacker, chances are I'm going to target your application with injection or cross-site scripting attacks, or to target your dependencies, as we've talked about so far. But keep in mind that the people who run a system, they are usually the weakest link around in the whole security chain. And if you watch Mr. Robot, if you don't, you should definitely watch it. It's great. It actually draws a very accurate picture of how hacking can happen in real life. And when the characters in the show talks about hacking, usually they're targeting the users of a system through social engineering, through phishing attacks. And there's another group of people you can target who are the developers of a system. Perhaps you can brute force your way into the GitHub account or find known account leaks and password leaks from other sources, and then in that way, try to gain access to the source code for the system that you're attacking. But there's another group of people around a system that turns out you can attack with great efficiency, and those are the authors for the dependencies of your application. And this happened a couple of weeks ago. A security bounty hunter posted a thread, an amazing thread on GitHub, detailing how he was able to push access to some 14% of all NPM packages. They include the likes of Express, React, Redux, Modernizer, MySQL, and the list just goes on and on. All in all, those packages account for 20% of all monthly downloads from NPM. That's 1 in 5 packages you or anybody else have downloaded from NPM could have been compromised. Let that sink in for a second, because I really need to drink some water. So this bounty hunter used some sophisticated method to gain access to these accounts. That's really hard to protect against. Not really. Like we mentioned, he was using brute force, trying out different variants, as well as combining that with account leaks that you get from other sources. Again, trying different variants on top of that. And in some cases, the NPM credentials were just in plain sight on GitHub. And our security is not helped by the fact that so many developers just have such a cavalier attitude towards the security of their accounts. And it's really hard to not feel let down when clearly people are just not taking basic security seriously. And as a result, it endangers themselves, endangers the rest of the community that depends on them, as well as all the users for the system that we're building on top of their packages. And once an attacker is able to compromise the package, there's just all kinds of things they can do. So now I'm going to show you a very simple way to attack a Lambda function with a dependency. The interesting thing about Lambda is that in the execution environment, you get a number of environment variables that are really useful for an attacker. You can get the access key and access secret for AWS credential along with the session token. And for testing to test this out, I put together a compromise package which I created myself. Now it's titled, "Do not download this package." And when I looked this morning, I found there's over 200 downloads. We're screwed, aren't we? And suppose I'm an attacker, and this package just, all it does is line number 13, doesn't do anything. But once I'm able to compromise the package, I can put some additional code so that when it's being initialized, I will just collect your environment variables and then send it to an evil URL that I have running somewhere to collect them. And then behind my URL is, of course, a Lambda function that will look for evidence that there's an AWS access key, secret, a security token, and so on. And then ping it to an SNN topic that goes straight to my email. And to my surprise, it worked way easier than I thought it would. And then I put it in my terminal and see, does it actually work? Can I do stuff with this credential? And it did. to my dismay, I was able to use that and list my S3 buckets because I intentionally left the permission on my function to allow listing of my S3 bucket, and that's the only permission you can do. But still, that was just way too easy. It took me half an hour to put a demo together. And I thought, well, would this work if it was a transient dependency instead? So again, another package that depends on the original package. And again, seriously, what is wrong with people? I got 40 downloads for a package that's called do not download this package neither. And of course, it also worked, so that's doubly not great. And then I remembered the default in NPM is that it puts this character. It means that it's going to grab the latest compatible version. So if I'm an attacker, I publish a new patch update to your package. And the next time your code is built on your CI box, bang, I'm in. Without even you have to do any code change, and I have access to your AWS credentials. So well done me, yay. So that's not so great. And I guess the takeaway from that is if you're using NPM, use string wrap, which basically all it does is locks your dependency to that specific version, and that's the same for your transient dependency as well. Or if you go up to, if you upgrade to NPM 5, you will do this by default. I actually got this demo working as well. Is anyone interested in seeing in live? Yeah, sure. Okay. Please don't look at the background, because that's one of the new games that we're working on. Security fail. Okay, also another thing to remember is that let me show you the code very quickly. I was so paranoid that someone would actually download my package and I have the moral dilemma of handling the AWS credentials. So I actually put a bit more code in there so that you will only trigger if there's some environment variable set that tells me where to send the credentials to, and also to avoid DDoSing myself as an attacker, I also check or look for the AWS key and the secret first before I do anything. And on the attacking side, we've seen where that works, and I've got two functions here as victims. One with a direct dependency on the compromised package, another one with a transient dependency on the package. And the compromised package, the evil code will only run the first time. So hopefully this will still work. I don't think I'll run it again. Everything is not awesome despite what it says on the screen. So if I now refresh, yep, there you go. That's my credential. I know I'm being filmed and recorded, but I'll delete this afterwards. So don't get any smart ideas. So all I need to do now is paste it in, AWS S3 list. And there you go, my buckets in my S3 account. So if you're an attacker, again, it's too late to tell you not to watch this now. But it just goes to show this is a really bad problem that we're probably not thinking about enough. Imagine the worst case scenario. An attacker is able to penetrate even a small percentage of packages in your ecosystem. Now he is able to then collect AWS credential at a massive scale for many people. And before we even realize there's a problem, chances are we've already been paying thousands and tens of thousands of EC2 costs for their Bitcoin mining business. And this is not a problem that's specific to Node.js or NPM either. Package management is a common problem across pretty much all languages, all runtimes. And regardless whether or not you are using NuGet or Maven, if we are still dependent on the authors of our dependencies to take basic security seriously. And I've been around most of my time in the .NET, and I've seen enough shocking things in both .NET and the Java world to have no confidence that people are taking their accounts seriously. So once I realized this is a problem, this is freaking me out really badly. So now our first line of defense has been breached, the attackers is in, they're able to get access to our accounts. The next line of defense becomes very important now, which is the IAM permissions that we assign to our functions that determines who can call the function, but in this case, more importantly, what can the function actually do. The rule of thumb here is to always apply the least privilege principle, which is basically what it says on the tin, and also applies to use of to VPCs as well. If you've got sensitive resources that you're trying to protect behind a private VPC, then don't leave a less secure and public-facing Lambda function in the same VPC unless it really needs to, because in the event that that function becomes compromised, now the attacker can use that function as a doorway to gain access to your sensitive resources that you're trying to protect with a private VPC. Another thing to consider is that the default behavior in the serverless framework is to use one role for all of your functions in the same project, but it's possible and it's recommended that you should use per function policies. And the way to do that in serverless is to specify what role you want to use for each function, and then create a role with CloudFormation as CloudFormation resources that you create as part of your deployment process. But as you can see, it's quite a bit more work. In fact, I think there's enough friction to your development flow that requires constant diligence and discipline from the developers, which is another way to say that no one's going to do it, right? Because I know I should, but even the guys that work with me knows I actually never did this because it just adds so much more work in terms of my day-to-day flow from having the idea and working on a feature to remember, oh, right, I need to create this massive CloudFormation template every single time. And then the shortcoming of the current system is that your IAM policies are not versioned with your Lambda function. So in the scenario where you have multiple versions of the same function being actively used at the same time, possibly through different aliases, then it becomes hard for you to add or remove permissions. If you try to add a permission with a new version, then you're going to give the same permissions to old version of the same function that don't need them, and therefore increase the attack surface for an attacker. But if you try to remove a permission with a new version, then you start to break older versions of your function that still need it. Fortunately, I think since the update to Serverless 1.0, this is a lot better because in each stage is now deployed as a separate function. So you have that isolation by function, and it's far less likely for you to need to have multiple versions of the same function at any one time. And given the ephemeral nature of Lambda functions, chances are all of your functions are written in a stateless way, and that's certainly how Amazon wants you to do. But it also means that more than ever, we now have lots of states that are stored in systems outside of our function that we still need to protect, both in transit, but also, just as importantly, whilst they're at rest. Fortunately, there's a number of services from Amazon that actually support server-side encryption out of the box, such as S3 and certain instances of RDS, and more recently, they also announced support for server-side encryption for Kinesis streams as well. And where that starts to fall down is with API Gateway, which are always publicly accessible. So if you have internal APIs that are only supposed to be consumed by your own services, you need to take the extra precaution to secure access to them, maybe via API keys that you can specify, or preferably using IAM roles. And you can specify both very easily within the serverless framework. And as we talked about before, you really should minimize the amount of access your function have and apply the least privilege principle all the time. And one of the often quoted benefit of Lambda is that you don't pay for functions that you don't use. The flip side of that is now you're also much less likely to delete them once you don't use them anymore because they don't show up on your monthly bill. And by the fact that they don't get used and also probably not actively developed on, it means they're also less likely to be secure and up to date, so that they're probably going to be sitting there as an attack surface for your attackers, with old dependencies that have known vulnerabilities that attackers can exploit. Which is why Amazon advised that we should delete old functions that we no longer use. Whilst it's all well and good saying that, I actually find it's a lot easier said than done, because identifying ownership of a component in any sizable IT organization is really challenging. The owner of a system could have left the company already. There could be things that are sitting there doing some useful things that no one knows about, or things that are not regularly being used but are crucial when it comes to disaster recovery. For example, if the people that are not in the organization anymore, how do you identify what components can you safely delete? And that problem becomes much worse with Lambda, because instead of a component with many endpoints and many subsystems, you now have many individual functions that you need to identify ownership of before you can know what can safely be deleted. And so moving on, let's talk about denial of service attacks. With Lambda, you can scale up very easily, very quickly and very aggressively. So chances are you can just brute force your way through a denial of service attack with Lambda, but it's going to cost you still, because every invocation is going to count towards your monthly AWS bill, which is why the guys in the serverless community started to call denial of service attacks denial of wallet attacks instead. And whilst you may say, sure, I'll just turn on throttling and it's problem solved, and that's all great, except now you end up with a denial of service problem in the first place. So it's really a lose-lose situation, unfortunately, even though Amazon does have AWS Shield, which everyone gets the standard version for free, and automatically it protects you from network and transport layer attacks. And for a monthly fee, I think about $3,000, you also get some additional bits as well, including a payment protection against the additional cost during a denial of service attack for ELB, CloudFront, and Route 53, so it doesn't cover your Lambda costs yet. Hopefully that will come in the future. Another thing to keep in mind is how Lambda handles processing error for async event sources such as S3 or SES or SNS. By default, you're supposed to retry twice and then go through the dead letter queue if one is assigned. But the research done by the guys from Opsgenie actually found that the number of retries can go up to as many as 6 on a very small percentage of cases. So now if an attacker is able to trigger error in processing for an async source, then they can start to really magnify the size of your attack. And if you combine that with the regex denial of service attack we talked about earlier, combined with accidentally having Lambda functions with a very long timeout, then those costs can really start to build up very quickly. And okay, let's talk some nice things. Back in the days, we have servers, and after some time, those servers tend to become infested with viruses. So by removing the servers from our grasp, we also remove the risk of having long-lived compromised servers, which is probably more than what you can say about your smart fridge at home, which is probably hacking the NSA right now. But with Lambda functions, you still have to remember that containers are reused for performance reasons. So you should avoid putting sensitive data like credentials and so on in the temp folder, because as we showed, an attacker that's compromised one of your dependencies can easily get access to that folder and start to send information out and start probing what can they get from that folder. Another thing that disappeared with the servers are all the web frameworks that we use to develop and deploy and run our code. And well, they've served us well for many years. I'm sure we all have our favorite web framework, but they've also handed us a loaded gun. Troy Hunt was here in this very room a couple of weeks ago, and he demonstrated how easy it is for developers to just accidentally leave directory listing option on. And he showed how you can use Google Doc to find people who's left the web.config publicly exposed, so that you can see their SQL Server connection string with their username and password and so on. And in some cases, people even left their entire SQL backup publicly available to download on the internet. With Lambda, hopefully that kind of risk is all gone, because if you want directory listing, now it's a feature that you have to implement, so chances are you're never going to implement it. But we still have to worry about Bitcoins, or specifically what your AWS account is going to be used to mine if you lose your credentials. And the internet is just full of stories of developers accidentally leaking the AWS credential on the internet, and attackers being able to use to spawn up EC2 instances to mine Bitcoins. And I've got a feeling that many more incidents happen. They are just not publicly reported because we want to save face. Even within my very small social circle, and you probably met half of them already, I know of two cases of companies being compromised, and in both cases, they incurred over $100,000 worth of damages, which Amazon did eventually pay and cover because both of them are really big customers for Amazon. And whilst I was researching this problem, I actually found a very nice way to prevent this kind of problem in the first place using Git pre-commit hook. And I also know for a fact that Amazon actively scans public GitHub repos to look for active credentials and warn the owners of those credentials. But they are not the only ones looking either. As some of the story has mentioned, one instance, the developer left the credential on the internet for about 5 minutes, and that was enough for an attacker to then launch a bunch of instances. So by the time he woke up, he was faced with $60,000 EC2 bill. And then the interesting thing I learned is that when an attacker is able to get your AWS credential, they tend to launch instances in bizarre regions like Sao Paulo or India, places that you wouldn't normally go and have a look. So it's good practice for you to enable to monitor any sort of activities, such as launching an EC2 instance in regions that you're not actively using. So chances are you're probably going to be using 1 or 2 regions at most. So enable CloudWatch Event, or sorry, CloudTrail on all of your regions and monitor for activities in regions that you're not using, especially now that Amazon has enabled the cross-account and cross-region event bus for CloudWatch Events. And you should also set up billing alarms as well. Of course, this is not going to save you in every single case, but hopefully you catch enough cases that the attacker launches instances in some weird region you're not using, then you get alerted very quickly. How are we doing on time? 5 minutes, okay. Let's talk about bulkhead. It's a technique that's used by ship makers to compartmentalize a whole bridge. And it's also an architectural pattern that's been popularized by Michael Nygaard in his seminal book, Release It, and it's been adapted in the Hystrix, which is a library by Netflix. And as a developer building a serverless architecture, there's actually several bulkheads that you can build into your infrastructure as well. Firstly, applying the least privilege principle with per function policy. So you have some compartmentalization at a per function level, but also useful to have account level isolation as well, so that in the case that one of your non-production accounts is compromised, at least the attacker can't use the credentials to do damage against your users' data. So we've covered a lot of things. Let's have a quick recap before we open up for questions. That your dependencies, application dependencies, is probably a much bigger attack surface than you realize. And OWASP top 10 is still very much applicable whether or not you're running your code inside Lambda or on EC2 instance. You should always sanitize user input, but also sanitize the output from your functions. Always apply the least privilege principle and also use per function policies as well. You have a lot of data stored in the external services, so secure them at rest as well as in transit. And when you're done with a function, try to delete them straight away if you can. Denial of service is the new denial of wallet attack. AWS Shield gives you payment protection, but it doesn't cover Lambda yet. And the eventual destiny for any server is to become a hotbed for viruses. So no server means no OS attack and no long-lived compromised servers. Saying that, I know everyone's going to tell me, but there's a server somewhere. Sure, but it's not being managed and secured by people who actually know what they're doing. And also those servers are well, and also those servers are ephemeral and short-lived as well. And don't become a Bitcoin miner for criminals. Safeguard your AWS credential and compartmentalize a security breach using account level isolation. And finally, please apply common sense and use a secure password for your NPM or NuGet or Maven accounts. You can find me in all of these places. I'll put the slides on the meetup page in the comments below. And a bit of a shameless promotion. I'm actually running a course on building serverless architecture with Lambda. in September with Safari Books Online. You can sign up for free if you get an account with Safari Books Online, or just get a free trial a couple of days before the registration finishes. With that, thank you very much for listening. Okay. Good.
Thank you very much, Ian. That was a great talk. Do we have any questions? We've got 5 minutes for questions before the second talk. No questions? Come on, I need a few questions while Raj is setting himself up, so no? Can still find... All right.
Tell us about your course.
Okay, so this is a 2-day, 6 hours in total course where basically I talk about everything from how to create your first function in the management console, to how to use the serverless framework, to centralized logging, distributed tracing, monitoring, alerting, security, which you've heard about, step functions, design patterns, and pretty much everything I've learned about serverless in the last year and a half, I guess. So it's basically my entire brain dump on the serverless. So, and it's free. Did I say it's free?
I think it's free. We have a question over there.
What's your single biggest problem with Lambda at the moment right now?
What do I think is the biggest problem with Lambda? Is that the question?
Yes.
The biggest problem with Lambda, that's a good question. I think the biggest, as far as security is concerned, is your dependencies. Your application dependencies are really hard to monitor, to police. And as much as we can rely on services like Snipe to find known vulnerabilities, is all the unknown vulnerabilities that also scares me as well. And with just how easily I was able to compromise a package that I own, of course. But imagine the case that you've got two forces you've got the developers and authors of packages not taking the security of their accounts seriously, and then you've got attackers who are probably very good at taking over some of these accounts and publishing compromised packages, and there's no easy way for me to find out when, in fact, I have been compromised. That really worries me. The only thing I can think of is to be really stringent about applying strict policies, but as we talked about, it's much easier said than done because everything requires constant diligence. I don't know if that answers your question. In terms of the general things, the general problem with Lambda, there's the lack of a very good orchestration. That's one of the pain points I see. Sure, there's step function, but it's okay. I mean, I play with it. It kind of does the job, but it's not a very good experience to use right now. And in terms of monitoring as well, we are probably completely reliant on CloudWatch, and CloudWatch is not the best system for monitoring. If for the simple fact that it tends to go down when Amazon has outage with other systems. So we've been in places where Amazon's having an issue. We know our services are being interrupted, but we have no idea how much and whether or not it's recovered, because guess what? CloudWatch is also down, and I can't get metrics for my systems from anywhere else because it's all coming from CloudWatch. Those are just a couple of things that comes off the top of my head. I'm sure I can think about more later on.
Thank you very much, Ian.
Okay.
Thank you.
All right.